Smart Club has been around now for probably over a year when we first got together. And the first time I met the Smart Club guys was at a dinner with Charles Bradshaw Smith, who sat there at the back. And we decided that there would be a better way for cities and for decentralized energy and for new ways of working. So whether that's around smart cities, new types of energy system, social capital, and really improving the life of citizens, it was quite a meeting of minds, actually. And just to say, we're really excited to be here with the Smart Club guys today. It feels like this room today is part of an actual revolution, which has been, 18 months in the making. So I've just given you my speech I was going to give at dinner tonight, so I've got another day to think up some stuff. Anyway, we're good to go, yes? Okay. I want to talk about digitalisation, and it builds very nicely from Nick's presentation around the Internet of Things and connectivity and all that IT stuff. Firstly, I'd like to show you a quick video, if that's okay.
Our world is becoming ever more connected. Billions of intelligent devices and machines generate massive data, bridging real and virtual worlds. Complex data now play a crucial role in the way we move, live, and work, the way we plan and create products and services. Turning the vast amounts of data collected every day into value is a key success factor for companies, economies, and entire societies. We have the domain know-how to transform the big data generated by our systems and products into rich information that enables smart choices. Our data-driven services monitor power plants to guarantee reliable energy supply. Our software and IT solutions teach wind powers how to produce more, and our building management systems teach buildings how to consume less energy. We enable our customers to intelligently automate processes across the entire life cycle of their products. And by simulating real-world objects by means of digital twins, we help them optimize their manufacturing processes. Our intelligent traffic management systems help moving people and goods faster, safer, and with less CO2 emissions. And we develop sophisticated medical imaging systems that help doctors make better decisions faster. We seize the data opportunity to create real value.
Okay, so the reason for showing you that video is very much linked with this smart city thing we're talking about today. You would have seen there, not individual siloed industries, but you see racing cars, you see traffic management systems, you see energy systems. Key theme that's linking this, and I go back to the interoperability around communications and the Internet of Things and connected devices, is data. So from an energy perspective, and I did mention while I was waiting for the slides to go, my first ever talk publicly was in this very room when we were first talking about the smart meter rollout in the UK. My background is in utilities. And it's so much more now than just smart meter data. If we look here, the amount of data that's available in energy systems, we're probably down there at the bottom in terms of what we can deliver around smart metering infrastructure. Digitalisation is a huge theme from us with energy management and how we digitalise all these new energy systems. I'm a huge fan of decentralised energy systems, and I'm going to go on and talk a little bit about a project that we're doing in Manchester shortly. But if you think about the Internet of Things, if you think about connected devices and connected assets, one of the things we're really interested in is connected controllable assets, because it's all very well connecting something and creating and collecting data, but what are you going to do with that? Personally, I'm responsible for defining some of these new business models that enable cities and communities and local authorities to derive revenue streams where they weren't before. We're all in a place where, budgets are being cut, and I echo your point earlier about what the government seems to be doing to community energy. I sit on the board of Community Energy England. It's something very close to my heart. Here's a really interesting stat for you. In 1947, 50% of local authority revenue came from local utility companies. Just think about that for a second. So we see two trends from a Siemens perspective. We see electrification, electrification of heating, electrification of transport. And we also see increasing digitalisation, as I'm talking about communications and data. One important thing is around society and the changes we have in society. I know this is something that's really core to the vision and the ethos of Smart Club, is how do we enable societal change? Whether we like it or not, we've all got smartphones. Whether we like it or not, we're all in a digital age already. People are talking about this stuff happening in 2020, 2030. It's happening today, right now. It's happening in our cities right now. Digitalisation, electrification, and the enabler of new types of social interaction are key here in deriving new business models. And where does this converge? It converges in cities. We're already seeing Nottingham creating their own energy company. Glasgow want to create their own energy company. We talk to a bunch of cities who want to create their own energy companies. The reason why they want to do that is because they want to derive value from the energy assets that are already in the city. The good news is there's already a bunch of assets in cities. We have hospitals with underutilised CHP. We have retail outlets with backup generation which isn't used. We have flexibility around demand response. These things are already existing in our cities today. One of the things that we're trying to do is to create smart districts and smarter districts, not just from an energy perspective, but also involving mobility and healthcare. So we're already working on the city of tomorrow, and this is just a little picture of the future. And I put this up because this slide is actually 2 years old. Now this stuff is happening already today. Grid talks to buildings. We're doing a project already with Glasgow City Council where we've connected up a bunch of their council buildings, connected into their building management systems, and are already defining the flexibility around that and using that for demand response with Scottish Power, the local DNO. Mobility is a huge, huge topic, and it was mentioned before. We're working on some really innovative car club type models where we use electric vehicles which are shared by the community. They're shared by the community, used by the community, and what we're also doing is putting charging facilities in the centre of cities. When you link that to traffic management systems, think how good that could be if people use the car club and the traffic management systems give them priority into the city to the self-sustainable generation pods. Power coming from renewable resources. We've had over the last 6 months, particular Saturday, more renewable energy on the system than ever before. Despite the current removal of some of the support from government, we still see there's a huge part that renewables play in our energy system. We've got intelligent buildings with zero emissions. We've got that already. Next time you're in London, please do come and visit the Crystal, which is our sustainability building at the Royal Victoria Docks. Decentralised energy I'm going to talk about shortly. Again, transport solutions. And what connects all of this stuff is IT, the Internet of Things, connected assets. This is why I put this up, because it is over 2 years old. This stuff is happening today. So we're working on a project in Manchester, which is a Horizon 2020 funded project called Triangulum. This is one of their lighthouse smart city projects, and it involves 3 lead cities, Manchester, Stavanger and Eindhoven. We've been working on that project for over a year now. We also have a bunch of follower cities and 3 work streams. Siemens is responsible for the energy work stream, but there is also ICT and a mobility work stream. We're spotting the same themes here: energy, mobility, ICT. We're working with the City Council and both the Metropolitan University and also the University of Manchester. It was mentioned earlier again, we're creating an open data platform where all this data can be collected and used by the citizens of the city. Some of the interesting business models that you see from Uber or Airbnb. My particular favourite is CityMapper. Who uses CityMapper? It recognises what city you're in and then plugs into the transport data of the city you are and tells you where to go. Open data enables that. When Transport for London made their data open source, within a year there were over 300 applications made and made available for smartphones to help people get around the city. This project in Manchester is down the Oxford Road corridor. Who knows the Oxford Road? Who's been to Manchester? Who's ever nearly been hit by a bus on the Oxford Road in Manchester? It's the busiest bus route in Europe, I'm told, by Manchester City Council. What we're looking to do is connect up a bunch of existing energy assets. You'll see the Metropolitan University there on the left in the blue, University of Manchester, and also, as you go into the city from this picture, the City Council assets as well. We've already done a building survey on the art gallery and made recommendations that saves around 40% of that energy. That's just one building. But what we're actually trying to do here is to connect these buildings and the energy assets within these buildings into something called a virtual power plant. That then allows us to operate the buildings and all the generation assets, distributed generation, in all of those buildings and facilities as one. And I'd like to explain. So I've talked already about the data platform. We're working with the councils. We want to create a multi-owner, multi-portfolio virtual power plant. Multi-owner means some of the assets are owned by the City Council. Some are owned by the Metropolitan University. Some are owned by the University of Manchester. This has never been done before in terms of a decentralised energy system, because what normally happens is all of the decentralised energy assets are owned by one particular owner or one asset owner. What we're trying to do is to create a new type of disruptive model whereby we can take decentralised energy assets from multiple owners and use them as one and create additional revenue by using these in markets. I've already mentioned building management systems. What's really, really important here is the creation of a new type of aggregation model. So we are currently looking at generation assets. We'll have about 3.5 to 4 megawatts of generation assets within that Oxford Road corridor, which we will be able to control. If you extrapolate that and think about some of the stuff that Hypercat are doing, where we've got connected devices and connected appliances, all of a sudden you get an aggregation model which you can control and you can utilize and you can create new business models from. And the identification of additional revenue streams is really important here for the reasons I described earlier. The City Council want additional revenue streams from the assets that they've got. The universities, they're quite happy to have additional revenue streams from the assets that they've got. And we're also putting some electrical storage in there, so we've got a 500 megawatt battery going in there. So in terms of the learning objectives, firstly, we're just going to prove that we can do it. We're going to prove that we can connect to these assets, and we're going to prove that we can create this type of decentralized energy system. Then we're going to optimize that system. We're going to then look at the markets. We've already identified 17 different potential revenue streams in ancillary services markets existing today, but also in additional services that can be offered. We're going to optimize that system once it's all connected, and the first installations are going to happen in February. It's a 5-year project, by the way. And we're also going to model, and this is really important, can we create microgrids? Can we decouple an urban energy system from the existing grid? It's going to be hypothetical, because I'm not going to be the person that's going to press the button to decouple all those assets from the grid. However, we're doing a bunch of research around, can we create smart, sustainable, self-sufficient energy districts in an urban environment? And this is the first project of its kind. And I'm very conscious of time, and Lee's waving at me from the back with the two. Please do come and talk to me on the stand afterwards. I'm here for dinner. Some of these new models are really, really disruptive. They're disruptive from a city perspective, but make no bones about it, they're disruptive from an energy market perspective as well. Because the wholesale market, the supply market, and this is very close to my heart because I implemented both of them, is ready for change. We believe this type of model, this decentralized energy model with energy storage, is game-changing to create self-sustainable energy systems. And just finally, another example which is actually live and has been installed in the Savona campus in Genoa University. We've created a microgrid there, which is a self-sustainable campus. It's been operational since 2014, and we've already seen a 33% reduction in energy use and CO2 use. That's another R&D project. And I just want to leave you with that thought. If we can utilise the energy assets that are already within cities, if we can use them to reduce carbon, and more importantly, if we can use them to enable cities to create new revenue streams with new business models, that's why I said I feel like we're at the start of a revolution. Thank you very much.